All right, quick recap. So we're dealing today with trapezoids. Trapezoids are four-sided figures in which two sides are parallel, but the other two sides are not. The parallel sides are called bases. The non-parallel sides are called legs. An isosceles trapezoid is one in which the legs are congruent. By the way, there's a pair of base angles for each base. A and D are the base angles here, and then B and C are the base angles here. In a isosceles trapezoid, the base angles will be congruent. So how are we going to solve for what angle D is? And I think I'm even going to extend this problem. I want you to find the measure of angle D and the measure of angle F. Well, the measure of angle D is going to be supplementary to angle C. So measure of angle C plus measure of angle D is going to equal 180. Why? I'll tell you why. Because these are same side interior angles, and these are parallel lines. So when two parallel lines are cut by a transversal, same side interior angles are supplementary. So I can find the value of D by substituting in 65 for angle C, and then solving the equation by subtracting 65 from both sides. And the measure of angle D is going to be equal to 180 minus 65, and that's 115. Everybody okay with that?
Yes, sir.
Now, if I wanted to find the measure of angle F, which is the extra part I gave you, the measure of angle F and the measure of angle C are equal because they are both base angles on the same base. So the measure of angle F will just equal 65.
So say you were trying to find base angles, so you would say the base angles of C and F equal 65.
Yeah. So the base angles of base CF are both 65. The base angles of DE would both be what? 115. And then these two would be supplementary, and these two would be supplementary.
Does it get harder to decide like?
Nope.
No, that's it.
That's it. So here, why don't y'all do this problem? I want you to find the measure of angles P, Q, and S. All right, let's see what we get here. So the base angles that will be the same are angle R and angle S. So we immediately know that the measure of angle S is equal to 106 because those are base angles. Notice that top and bottom are not always bases. This is oriented a little bit differently. The measure of angle Q is supplementary to the measure of angle R. So the measure of angle Q is going to equal to 180 minus 106. So that's going to come out and be 74. And then the measure of angle P is either supplementary with S or congruent with Q. So it'll be 74. Is everybody okay with that? Does anybody have any questions? All righty, let's move on. So the other thing that's interesting about isosceles trapezoids is that their diagonals bisect each other. So I could give you a problem where I give you the two diagonals of an isosceles trapezoid in the form of variables. You'd set them equal to and solve. Now, I want to caution you about something. What else has congruent diagonals?
Rectangle.
Rectangle.
That's on our bone right here.
Right. So a rectangle has congruent diagonals,
And 90-degree angles.
and an isosceles trapezoid has congruent diagonals, but they're not both parallelograms. So just because something has congruent diagonals doesn't make it an isosceles trapezoid. Just because something has congruent diagonals doesn't make it a rectangle. What else would you need to know to decide whether it was a rectangle or an isosceles trapezoid?
Right angle.
Right angle. Parallel lines.
Yeah, you need to know how many parallel lines there are. So if there's two pairs of parallel lines, it's a parallelogram, and parallelograms with congruent diagonals are rectangles. If it only has one pair of parallel lines, then it's a trapezoid. So you need to remember to be able to make that distinction. We okay? All right. The other thing is that trapezoids have midsegments. Do you remember when we had triangles that had midsegments? And the midsegment of a triangle was half of its base. Well, here, the midsegment of a trapezoid is half the sum of its two bases. So if you know that you're connecting the midpoints of the legs, you're a midsegment. Not the midpoint of the not the midpoint of the two bases, but the midpoint of the two legs. Okay? So what does that mean? Well, using the midsegment of a trapezoid theorem, we should be able to solve for x here. So we're told that QR is a midsegment. It's right up there in the I'd call that given information. So how are we going to set up an equation? And by the way, this isn't on your formula sheet, so you're probably just going to have to memorize this. So if you have a midsegment, that's going to equal 1/2 the sum of the bases. And in this case, the base is LM and the base is PN. So my mantra has always been, for this stuff, for solving these problems, get an equation, plug in what you know, and find out what you don't. Well, I don't know about that.
Yes.
Okay. What does that mean?
I mean, read the problem and wiggle your paper. Wiggle your pencil on your paper. Write what you know.
Okay.
And go from there.
Read and wiggle. Okay. I like fill in what you know, find what you don't better. So what do we know? We know QR is equal to x plus 2. We know that 1/2 is just 1/2. We know that LM is 4x minus 10. And we know that PN is 8. So by the way, when I get done, since I'm going to be adding this and dividing by 2, and this is smaller than this, I know that if I somehow get an answer bigger than 8, I'm automatically wrong. My answer has to be less than 8, because 8 is the longer side, and I'm going to be adding some number less than 8 to it and dividing it by 2, so I can't be all the way up to 8. So the first thing I'm going to do is I'm going to combine like terms in my group. That's how you solve an equation. You CLT first. So combine like terms. So, or you simplify groups first. So 4x minus 10 plus 8 is going to be 4x minus 2. We okay with that? Then you distribute. X plus 2 is equal to 1/2. I'm going to go ahead and distribute that 1/2. So 1/2 times 4 is 2, and 1/2 times 2 is 1. Now I've got variables on both sides of the equation, so I want to get a variable on the one side so I can isolate it. I think I'll subtract x from both sides, and that'll give me x minus 1 equal 2, and they'll add 1 to both sides, and x will equal 3. So what is x? X is 3. Everybody okay with that? So, what's 3 plus 2? 5. Way too long of a response on that. What's 4 times 3?
12.
Minus 10?
2.
2. So if I added 2 and 8 together, what would I get? 10. And 10 divided by 2?
5.
So 10 divided by 2 and 5 are the same answer. The sum of these two bases divided by 2 and this is the same answer. I checked my work. I'm 100% I'm right, although it was very painful to check the work.
Geometry, maybe.
So can you not?
Geometry.
Okay, hold on. I got a question. What?
Can you not, just instead of doing the 1/2, can you not like, what?
I don't know how to proceed without getting rid of the parentheses.
Why can't you just multiply 1 by 2 instead of 1/2, like the other one by 2?
So multiply both sides by 2. So just take away the 1/2 over here and multiply by 2 over here and get 2x plus 4 equal 4x minus 2. That would also work. Yeah, multiplying both sides by 2 would get rid of the 1/2, which would eliminate the parentheses because...
And the fraction.
Huh?
And you didn't have to do
Yeah, I mean, 1/2 times 4 is not a difficult fraction.
Yeah, it's not, but I want to.
Okay. Yes.
Could you go over the last two steps real quick?
Go over the last two really quick. Okay, so the last two, I've got x plus 2 equal 2x minus 1. I subtract x from both sides. When I do that, this x cancels out. 2x minus x is x. And then I add 1 to both sides, and that's where that becomes 3. You okay with that? All right. So y'all do this one. What do we get for x? 6. Let's see if I get 6. So the way I'm going to set it up is I'm going to take the mid-segment, Mn, and I'm going to set it equal to 1/2 QR, which is a base, plus PS, which is a base. So that'll be 2x plus 11 equals 1/2 times 10 plus 8x minus 12. I will solve what's inside the parentheses, so that'll give me, or simplify what's inside the parentheses, so that'll give me 8x minus 2. I don't mind working with fractions, so I'll go ahead and distribute. Especially when all the numbers are even, I don't mind multiplying by 1/2. So that'll be 4x minus 1. I'll solve by subtracting 4x from both sides. Daryl, you with me on this one?
Yes, sir.
So when I subtract 4x from both sides, I get negative 2x plus 11 equals negative 1. Then I'll subtract 11 from both sides, and I'll get negative 2x equal negative 12. And when I divide by negative 2, I get a positive 6. Question?
For mine, you didn't do the 10, how it would be 5 if you multiplied it by...
So you went ahead and multiplied through first by 1/2? I went ahead and simplified these two numbers and then multiplied by 1/2. But I mean, I don't really know that there's an advantage to do it one way or the other. I think what you did is fine, because 5 minus 6 is still going to come out to be negative 1.
Yeah, I just didn't know that you put them together.
Yeah.
I see.
Does that make sense? Yeah. And what you did is totally fine. Don't feel like you have to do it my way. Your way is just as good. And I don't think you save any time one way or the other. All right. So it also asked us what Mn was. So Mn can be found by taking the 6 and multiplying it by 2 and adding 11 to it. So that's going to be 12 plus 11, which is 23. Everybody okay with that? All right. So the other figure we're going to talk about is a kite. Now, a kite is a four-sided figure in which not the opposite sides are congruent, but consecutive sides, or sides that touch each other, are congruent. And it has two pairs of congruent consecutive sides. And that makes a kite. Now, interesting about a kite is if you have a kite, if you know something is a kite, you know that its diagonals are perpendicular. What else has perpendicular diagonals? A rhombus. So just because I tell you a figure has perpendicular diagonals doesn't mean you can immediately tell me it's a rhombus or a kite. You have to know whether or not it's a parallelogram or not. Interestingly enough, and the book doesn't tell you this, but if I have this shape right here, then this short segment is going to be congruent to this other segment, because this line actually ends up bisecting the shorter diagonal gets bisected by the longer diagonal. And the longer diagonal bisects the angles it touches. So that longer diagonal is like a super bisector. It bisects everything. Everything it touches, it bisects. Which makes these two bigger right triangles congruent and these two smaller right triangles congruent by hypotenuse leg. So in a kite, you're also going to have two pairs of inside triangles that are congruent and two other pairs of inside triangles that are congruent. So you'll be able to use CP/CTC a lot too. So what do I mean by that? Well, let's find the values of all of these angles here in this picture. So angle 1 is automatically going to be 90 degrees because I know that it is a kite, and a kite has perpendicular diagonals. Angle 2 we'll figure out in a second. Angle 3 is going to equal to 52 because this small upper left triangle is congruent to the small upper right triangle. because it's a kite. Now, the book won't tell you that officially, but you can go through some proof steps and make that claim and be fine. How would I make that claim? Well, if it's a kite, I already know that that line is congruent to that line. I know that the diagonals are perpendicular, and I know that from D to this point is congruent to itself. So by hypotenuse leg, the two triangles are congruent. So by CPCTC, 3 and 52 are congruent. But I'm just going to shortcut you and say, when you look at a kite, don't even go through all of that mentally. Just say, oh, the two smaller inside triangles are congruent, the two bigger inside triangles are congruent. That's my shortcut. And then finally, what's angle 2? Well, if this is 90 and this is 52, remember the sum of the interior angles of a triangle have to be what? 180. So the measure of angle 2 is equal to 180 minus 90 minus 52. So I think that's 38. Everybody okay with that? Yes, no? Okay. So go ahead and do this real quick. So right off the bat, we know the measure of angle 1 is going to equal what? 90, because it's a kite, and in a kite, diagonals are perpendicular. The measure of angle 3 is going to be equal to what? 36, because those two small triangles are congruent, so CPCTC. And then the measure of angle 2 is going to be 180 minus angle 3, which was 36, minus this angle right here, which was 90. So 180 minus 90 minus 36 is 54. Everybody okay with that?
Yes.
All right. So now we've opened the door to all of the different types of four-sided figures that exist. Sometimes you'll just have a weird four-sided figure that doesn't match up with anything we've talked about. That's just a quadrilateral. And they exist. In fact, if you were to draw every shape possible based on every length of line possible that was a four-sided figure, the most predominant figures would be quadrilaterals. However, aesthetically, you'll probably see more of these other shapes than quadrilaterals because we just like to make things that look symmetric. If you have no pairs of parallel sides, but you have congruent sides, that's a kite. If you have one pair of parallel sides, that's a trapezoid. If you have two pairs of parallel sides, that's a parallelogram. If you're a parallelogram, then you can be a rectangle, rhombus, or square. If you're a trapezoid, you can be an isosceles trapezoid. And what you'll have to do on a test is I'll give you some information about the figure, and you'll have to classify it. So if I say the diagonals are perpendicular, and that's all I tell you.
Rectangle.
Nope. It has to be a parallelogram with perpendicular diagonals, and it's not a rectangle, it'd be a rhombus. So you got to make sure you have enough information to tell me what it is. Because remember, a rhombus has perpendicular diagonals, but a kite also has perpendicular diagonals. Congruent diagonals could be a rectangular and isosceles trapezoid. So you need to make sure that if you're using these special rules, you already know it's this. If I tell you you have a regular figure, what is it? A regular four-sided figure. Quadrilateral is any four-sided figure. Most specifically, what's a regular four-sided figure? What does regular mean?
Square.
Yep, square is the answer. A regular figure means all the sides are the same, all the angles are the same. The only one that fits that profile is a square. So be thinky when you do this. All right. Real quick, see if you can do these two. This is kind of a sum of what we've done today. Be really careful about number 2. All right, we're running out of time, so I'm going to sum up real quick. So right off the bat, I know that angle 2 is 90, and angle 1 is 78. Angle 3 would be 180 minus 90 minus 78, which would leave me with 12. Angle 1 and angle 2 are not congruent here. So if you found angle 1 and then say angle 2 is the same thing, it's wrong. These are both same side interiors, are supplementary, but this is not an isosceles trapezoid, so the base angles are not congruent. So angle 1 is 180 minus 86, which is 94. And angle 2 is 180 minus 48, which is 132. Everybody okay with that? And it's posted on Edmodo, but here is your homework.